Welcome class. This is our lecture on ordinary differential equation, and today we are going to start with the first topic, that is formulation of ordinary differential equation. Ordinary differential equation. Alright, so first of all we must have the algorithm as to how we are formulating our differential equation. The first step is write the given equation. Alright, this is the first procedure. Then we will count the number of arbitrary constant. Second, count number of arbitrary constant. After that, we are going to differentiate the given equation with respect to x successively as many times as the number of arbitrary constant. So that is, differentiate the equation, given equation, with respect to x successively as many times as number of arbitrary constant. That is to say, if we have n arbitrary constant, then we will have to differentiate the given equation n times. So this is the third step. And fourth step is to eliminate the arbitrary constant. So this is our procedure as to how we are going to follow the step while formulating a differential equation. Please make a note of this algorithm. That is, given equation is given, then we have to count the arbitrary constant, differentiate it as many times arbitrary constant is there, and finally eliminate the arbitrary constant. So this is the procedure. Before I take up some question, I would like to make an important comment. That is, the order of a differential equation representing the family of curve is same as the number of independent arbitrary constant present in the equation corresponding to that family of curve. That is, I will write it down. Order of differential equation representing the family of curve is same as number of independent arbitrary constant in the given equation corresponding to that family of curve. That family of curve. This is the fundamental premise of doing that. So we can invariably check this result. First of all, we must understand what I am trying to say. All I am saying is that order will be equal to the number of independent arbitrary constant. Let's suppose I say that y is equal to a cos x plus b sin x is the solution of a differential equation. Alright, and we are having a and b as arbitrary constants. So here we can readily see that there are two arbitrary constants. So we can conclude very easily that the order of the differential equation that will be formulated by this will be 2. We will check it out. So if I differentiate it, y dash, that is minus of a sin x plus b cos x. Again if I differentiate, that becomes minus of a cos x minus of b sin x. So if we just take minus sign common, so this becomes our a cos x plus b sin x. This is equal to minus y, that is the first equation. So we have proved our argument that the order of this differential equation is 2. That is d square y by dx square plus y is equal to 2. So we were having how many? 2 arbitrary constant here, and the order is also so 2. So we have very easily demonstrated our claim. Now I am going to take up some of the questions based on this. First question that we will take up is, we have to find the differential equation for this equation, that is c. We can see here we are having only one arbitrary constant, that is c. So definitely we will have to differentiate it only one time. So this gives us a very important clue, that arbitrary constant number, that gives us the clue that how many times you have to differentiate. So this is the equation. If I write it as 1, and if I differentiate it with respect to x, I will get it as c 2 times y plus c dy by dx is equal to 3x square. Suppose this is our equation 2. Now we do not have to further differentiate because we have seen that only one arbitrary constant. Now I will use equation 1. I will put the value of c from equation 1 in 2. So I will put value of c from equation 1 in 2. So that is 2 times, I can see the value of c is x cube by y plus c whole square into y plus c dy by dx is equal to 3x square. So if we are going to do simplification, what we will get? We will get 2 by 3, I am bringing 3 here, and this s square and x cube, this become x dy by dx, and this one get cancelled for one time, and I can write it like this. So I am getting y plus c as 2 by 3x dy by dx. Alright, now I want the value of c, so I will write it as c is equal to 2 by 3x dy by dx minus of y. So we have got our c, and we have also y plus c we are having from this equation. So I will just put these value in equation number 1. Alright, so I'll do it here. So the value of c is 2 by 3 x dy by dx minus of y into, what is the value of y plus c? 2 by 3 x dy by dx whole square is equal to x cube. So this is how we have formulated the differential equation for this part. This is our first question, and I will take the next question now. Alright, so now we are going to take another question. That is, the question reads as, by eliminating constant a and b, we have to form a differential equation. From this equation, xy is equal to a into e to the power x plus b into e to the power minus x plus x square is a solution. And this question was asked in IAS 1992. So we will follow our standard procedure. First of all, we are going to write our equation, that is xy is equal to a into e to the power x plus b into e to the power minus x plus x square. Alright, we write this equation 1, or we can say the solution as given that xy is equal to this. Now I will differentiate equation 1 with respect to x. So I am keeping x as constant, I am differentiating it. So I can write it dy by dx plus, now I am keeping y as constant and I am differentiating x. So this becomes y. So this is a into e to the power ex. This becomes minus of b e to the power minus x plus 2 of x. Now do we need to differentiate once more time? That can be found out very easily because we are having two arbitrary constant a and b. So definitely we have to differentiate it once more. So I will differentiate again with respect to x. So when I am doing that, I will keep now my x constant and I will differentiate this one. So this becomes d square y by dx square. Now I will keep dy by dx constant and differentiate this. So this becomes dy by dx plus again dy by dx. So this becomes 2 times. So this is becoming what? Again a into e to the power x minus become plus and this becomes 2. Now we can use something from equation 1. That is, we can put the value of a ex plus b ex is equal to xy minus x square here. So I am going to straight away put it here. So I can write it as xy minus x square plus 2. So I can get my answer as x d square y by dx square plus 2 dy by dx. So this is our answer. If you want to present it more, we can write all of these in one line, one side, dy by dx plus x square minus xy minus of 2 is equal to 0. So this is our answer. Such kind of questions do come. Not many questions are asked from this area, but definitely they check our fundamental. But the favorite point of discussion over here is all the time order and number of arbitrary constant. If we are very thorough with this, we can understand this question. Now I am going to take the another question which is asking us to eliminate again arbitrary constants and formulate the differential equation. This is the third question. Here we have to eliminate a and b, and we are given equation y is equal to a sin x plus b cos x plus x sin x. So we will start following the procedure. First step is to write down the given equation. So we can write, given that y is equal to a sin x plus b cos x plus x sin x. This is equation number 1. Now we have counted the number of arbitrary constants, that is 1 and 2. So we are having 2 arbitrary constants. So we need to differentiate it twice. So again I will differentiate equation 1 with respect to x. So we get dy by dx is equal to a cos x plus differentiation of cos is minus sine, so that is b minus b sin x plus, you can differentiate it by UV method. This is sine of x plus x cos of x. Now this is our equation 2. We need to differentiate it one more time. So we will again differentiate with respect to x. So we get d square y by dx square is equal to differentiation of cos is minus a sin x. Sin differentiation is cos, so we will write it like this, and sin differentiation is again cos. Differentiation for this x cos x, we can write it as cos x minus x sine of x. So we are seeing here that here we have minus sine a sine x minus b cos x, and here. So this is the value of y. We can see it from here. So we can write this one as minus of a sine x plus b cos x plus x sine of x plus 2 cos of x. So we can write this as d square y by dx square. This is the value of y, so we can put the value of yes here as y. So we can write it as, we can put this minus sign on left hand side, and this becomes our answer. So this is how we formulate our ordinary differential equation. Thanks for watching. Please like, share and subscribe.